Well, thank you guys, everybody, for coming and joining our session. I hope that you're excited to find out a new way to detect all of your and debug your Java from your production code or from your production systems. Today we're going to talk about some fun things. My name's Nick Durkin. I am by this slide, a monitoring engineer over at OverOps. I'm here really to help you guys figure out how you can use this product, really give you a demonstration of what it is, and kind of talk about the different monitoring tools we've used in the past and how we can actually start doing this in a much better way. If you think about all of the current monitoring tools and what that ecosystem looks like today, we've all used a ton of different tools, whether it's the log analyzers of the world, the Splunks, the Sumo Logics, the Elk Stacks, to be able to determine exactly what's coming out of our logs from our systems, or whether it's the Apm tools, right? The performance monitoring tools that allow us to really get down to the root cause of or to get down to the performance statistics, right? To the time that it's taking for application to move through the system. Those tools being AppDynamics, New Relic, things like Dynatrace, right? All these tools have been great, except for they only do one thing for us, right? They hand us the haystack. And what I mean by that is it's our job as developers to go find the needle. The problem is, why did it break? They tell us what method it broke in. They can tell us what the stack was that it was when it broke. But at the end of the day, it's our job to go fix, right, and to go recreate that error in our pre-production environments. And that figuring out why takes a massive amount of time. So with OverOps today, what I'm going to show you, and actually I'm going to go straight into demo if that works for you guys, so you get to see the product. We're going to show you exactly how this can be done in an entirely new way that doesn't have to deal with that time frame and that recreation of errors and having to spend, or even potentially closing a ticket because you couldn't recreate an error. So what I'm going to do is I'm going to be bold and I'm going to actually do a live demo. Right? I know that works out for Microsoft every time they do it, so I figured I'll give it a shot. Right? OverOps is designed for one specific thing. It's designed to show you when, where, and most importantly, why your code breaks in production. The special part is why. That's what we always search for. We're going to do this for every single error and exception you have, right? For every HTTP error and logged warning, again, we knew what we wanted to log in the first place. Beyond that, we're going to do this for every single caught exception in our code, as well as every single uncaught exception. All of those black holes that kill threads that leave us with absolutely nothing. For all of these instances, we're going to give you the source code, we're going to give you the stack trace, we're going to give you the entire variable state that actually led to the error. Something very different. The way we're going to do this, we're going to give you the error by name. I'm going to give you the method that it actually came in under. I'm going to give you the quantity of times that it's actually occurred. But more important than that, I'm going to actually give you the error rate. I'm going to tell you that of the 22 million times this thing's executed in the last day, it's only errored 0.05% of the time. Very different than the 12,000 errors we're actually seeing. Beyond that, I'm going to show you when it was first introduced into the system. Under what deployment did I actually start seeing this error? The benefit here is with one click, we can get to all of the things that you need to actually solve this problem. No longer do you have to recreate this in a pre-production environment. On the left-hand side of the screen, you're going to see the stack trace. Not only will you see where this error was thrown, and here I can zoom in if we want to get a little bit closer. We're going to show the stack trace. Not only are we going to show where the error was thrown, but potentially even where the error was caught, as well as the line where the error was logged. Most importantly, I'm going to give you every value to every variable that executed throughout the entire stack. Doesn't matter which method, every value to every variable is now available from your production systems. Beyond that, I'm going to give you the last 250 lines of debug level logging, regardless of what your log level is set to in production. You do all of this with less than 3% CPU utilization. We do this, we're a native operating system agent. We're not a JVM agent, which means you don't add to your heap space. You don't add to your garbage collection. You don't add to your performance, right, your latency. The benefit here is now for the first time, you don't have to recreate errors. You don't have to question what actually caused your error, nor do you have to actually close a JIRA ticket because you couldn't recreate the error. Of course, you can send your tickets directly to JIRA from our application, but more importantly, we're going to integrate with the tool sets that you already have. So those log analyzers today, I'm sure everyone in this room, favorite thing to do, sift through logs? No? Come on. I see like 3 guys in there who Friday night it was logs as opposed to Netflix, right? Okay, me too.
Even worse is when your log server runs out of memory.
See, there you go. And now you have to question. What we're going to do for you is make your life infinitely easier. Without any integration, we're going to inject a link directly into your logs. Now, with a single click, regardless of whether you had the correct verbosity in your logging, you weren't sure if you captured the right pieces, now you have the entire source code stack trace and the variable state that actually led to the error. Right? Every value, every variable throughout the whole stack, so you no longer have to question. Right? And the benefit here, right, is of course you get to see those variables. The downside is, hey, there might be some personally identifiable information in these variables. Something that your security says, guess what, you're not allowed to have. The good news is not only are we built for your enterprise to be able to run under those Black Friday events with that 3% utilization and only 50 megs an hour of network transmit, we're also built for your security and regulatory commissions as well. We have a full featured set of what we call Pii Redaction, or PHI if you're in the health industry. But this allows you to redact any of this information at the most micro or macro level. You can do this by redacting it as regex, right? So if it looks, smells, or comes close to being a credit card or a social security number or any regular expression that you want, you can redact that at the source, never writing it to disk, never passing it across a network. You can also do this as a code identifier. So the reality is, even if the variable name or the field name inside the object, right, is a certain name by given, then now you can actually redact that as well. And then even at the class level, one of the things you'll notice, this is one of our production instances, so there are some classes that we redact. Our AWS credentials, our credit card classes, keychains, so forth. And this is available to have that full separation of duties so that you again, can meet all of your security or regulatory needs. This is, however, right now generally available for all JVM languages, right? So Java, Scala, Clojure, Groovy, JRuby. On the roadmap, we do have .NET, Node.js, and Python, but today, generally available is all JVM languages. The last thing that I'm going to show before we get Captain America up here to speak about how they're using this, no joke. We've got a Steve Rogers here from TripAdvisor to actually speak to us today on how they're using it inside of their environment. But before I do that, I want to show you how you can actually start proactively alerting. We've talked about how you see this in your logs and how you can monitor it. But how about let's automatically kick up JIRA tickets based on the code we wrote. Right, let's make sure when we have a new error or a new exception, we get alerted, and not only alerted, but even opened up a ticket. Right, so the interesting thing is we can filter on every possible portion of the system. So whether it's the actual server itself, whether it's the application by name, whether it's the method itself, right? Potentially being, all my S3 code, right? So I can go grab all my S3. And right now I'm seeing logged errors, I'm seeing caught exceptions, I'm also seeing logged warnings. And the warnings I don't necessarily care about, so what I want to do is I want to make this contextual. Let me know about every single logged error and my caught and uncaught exceptions. So now I have a view that's extremely important to me, right? I'm the guy who wrote the S3 manager. I also want to know every time I see a brand new exception or an error inside of my system. So I can quickly save this view. We'll call this S3 Nick, just for fun. Share this with my teammates so all my teammates can see this. And the benefit is from any one of these views, right, whether it's the one I just created or one of my favorites, which is new this week, this is going to show you every single error exception you've introduced into the system in the last 7 days. You want to know when we did our deployment? Right? You can see it. Right? The benefit here, regardless of any of these, you can now start alerting on this. So what we'll do is click the bell. With one click, I can now decide to alert whether it's a new error, whether I've exceeded a threshold, and I can decide how I want to be told. Do I want to automatically open up JIRA tickets, don't use PagerDuty, HipChat, Slack, so that I can make sure that this gets to me in the way that I want, and it can be delivered automatically. With that, and I'm sure there are questions, what we'll do is we'll have Captain America come up here and actually talk to him about how he's using the system, TripAdvisor, and then after that we'll have open questions and we'll show you through demonstration how we do those questions. So with no further ado, Steve Rogers.
Okay, thanks Nick. So yeah, my name is Steve Rogers. By night I'm Captain America, but during the day I work for Viator, which is part of TripAdvisor. We're the part of TripAdvisor that does what we call tours and attractions. So if you want to do a tour around Alcatraz, Eiffel Tower, Disneyland and things like that, that's where we cover. So I'm the Director of Software Engineering there. Just to give you an idea of the sort of traffic and things in our setup. So through Viator.com and our branded sites, we have about 7 million unique users a month. But a lot of our traffic and more traffic is coming through our APIs, especially all the TripAdvisor.com integration. We're 60 developers, mainly in Sydney, but growing more and more in San Francisco, just to get more overlap through time zones. Our main instances, we're running it purely in AWS with 100 odd instances there for our main production site. And we're sort of 3 front ends and 20 back ends. So it gives you a quick overview of our sort of size, etc. Something quite important is we are PCI level 1 compliant. So we have credit cards running through our systems. And as Nick mentioned, through OverOps, we obviously hide all those so they don't come through at all. Our software stack is obviously JVM based, so we're Java, Tomcat Linux, running in RDS with MySQL, Amazon Elasticache with Memcache, and Solar. So a fairly standard stack, fairly standard JVM tools, and probably what quite a few people here use at some point. And our monitoring tools, so we have 2 main tools we use for our application stack, OverOps and New Relic, and then we have other tools more for the ops department, Pingdom and CachePoint, and then PagerDuty for notifications, and Scalar we hold all our logs on. So that's roughly our architecture. Very simple slide, just sort of explain. You've got some front ends, we've got a whole heap of back ends. We've got integration with supplier systems, probably about 1,000 of those to provide real-time bookings and availability, etc. As I say, we do payments, we've got payment gateways, and then we've also got obviously a whole bunch of storage for each of our services. So that's a quick overview of our tech stack and how we run, and this is how we actually work. So we're an agile environment with about 12 teams, so each of those got say 5 devs or so in there. Now a few important things relative to this is that all teams are responsible for their releases and any team can release anything. Now that does give us quite a few challenges. You can imagine you've got 20 services there, or 25 including front ends, etc. So that means that every team needs to understand exactly how all of those work, or need to be able to troubleshoot and fix problems that occur with their releases, which it can take someone quite a while to come up to speed on all of those applications. So having the right tools in place to be able to troubleshoot those quickly is obviously extremely important. A few other challenges we have. So Viator's been around for about 20 years. We probably don't have any 20-year-old code, but we do have some old code. So we have some legacy code, which probably no one who's currently working there even wrote or changed. So that can be a challenge for troubleshooting as well. We do have quite noisy logs. I think we're not a huge site, but we're still creating about 100 gigabytes of logs a day, mainly going to Scalar. So we've got a lot of noise in there. A lot of people like to log just in case, and we've never gone through and switched some of that off, which may not be relevant anymore. So we are PCI level 1 compliant, so we can't take heap dumps in production. We can't obviously attach a debugger. We can't have developers going on to those production instances. So that stops us doing a lot of things that we'd like to do. Obviously a heap dump, that could include a credit card number, so we can't do those sort of things. So pre-OverOps, how do we debug production systems? I mean, it's probably not much different to how a lot of people have done at some point in their career. Maybe you're not that bad these days. But we have monitoring to look for 500 errors, etc. So whenever anything goes wrong there, then we get a whole host of warnings and alarms going off. And our logs start filling up with some noise like this, null pointer exception, which I'm sure everyone's seen. And then you look at the code and you go, well, that shouldn't cause a null pointer. How did that happen? And then you look back at the stack trace, so it does. And then you look at the code and said, no, I still can't work it out. Now, the problem here was actually an aspect around it, which was like hidden to us. So how do we actually solve this? Well, this is sort of a painful process that we've had to go through on occasion. So you have to roll back the release. You obviously looked and you know you can't find it. So you have to create a hot fix release with some extra logging in, deploy that to one box, put a bit of traffic to it, capture the logs again. Okay, now I think I fixed it, I've worked it out, you can fix the issue and you release it. And this time you keep your fingers crossed that you did actually fix it and you're not going to go through this process again. Now this took 3 full days. I mean, in other organisations where I worked prior to Viator and TripAdvisor, I was working for a software vendor. And I've had to go through this same process, but it probably took 20 days because it takes a while for a client to actually install a new release into their environment. So it can be even more painful for this. So what do we do today? So this gives a quick overview of what we use for the application tools today. We use New Relic for performance investigation. Great tool, but not here to talk about that. We use OverOps for our error investigation. We find those two tools complement each other perfectly. We also use a tool called Rigger to do end-user performance, browser-based performance. Again, good tool, but not talk about. We also have homegrown tools. We have some things around 500 errors, proxy logs, and we also have some tools where we actually monitor revenue. So if we started a reduction in revenue on a Canary release or something, then that obviously shows warnings there. Something that may not come up on New Relic OverOps. Deployments, we do Canary releases, we then smoke test. And the important thing is that teams are responsible for their releases, so they're expected to go on, have a look at New Relic, have a new look at OverOps, and confirm there are no issues before rolling it out to the rest of the cluster. And that works quite well to empower the developers to have that ability to own the release and own the responsibility of rolling it out. It also gives them a good ability to have a lot of confidence. We also have real-time alerting issues like Nick showed you. So this is a problem that came, it was a couple of weeks ago now, where we actually did a release and we had a performance degradation. Now this is a bit different than how we'd normally use OverOps, in the sense we wouldn't normally expect to use OverOps for performance problems. But when we looked at New Relic, there was nothing obvious of what was going on there. And then we got this email here. This was an email showing us there's a problem with our Solar searching. It was off Canary box, and this was an hour email, so we can see it was occurring a couple of times a minute. So we logged on to OverOps, and this is the view we actually received. So you can see up the top here, we had the release, the problem occurred. The cursor, you can't see the cursor. Okay, so at the top here, you can see the problem occurred, and we fixed it and released it the same day. But the important thing here is this view that it gave us. It decompiled the code for us. We could see all the code. It doesn't match exactly, but you can certainly easily work out what's going on. And importantly, you get this whole view of all your variables, so you can work out why did it fail. You can work out what scenario caused that by going through your stack trace and look at the incoming URL request as well. Now, this view here is probably the main reason why we use OverOps. The power of this view, I can't understate it. And what that also gives us is a few unexpected benefits of using OverOps. So we started using OverOps about 2 years ago when we did a major release, and we were having all sorts of problems with bookings failing. Our revenue was down, and it was just a pain to debug it and work out what's going on. We couldn't reproduce things in our development environment. As I say, we can't attach debuggers, we couldn't do memory dumps and all those sort of things. So what it gave us, obviously the variable values across the whole stack, that was huge for us. And it meant that fixing those hard errors, it could take minutes rather than days or hours, and that gave us a huge win. It also unexpectedly provided us a benefit of all those smaller bugs that you might have in your software that you go, well, that's not that important. One day I'll fix it. But to be honest, I can't be bothered to spend a day fixing it. But now, instead, with OverOps, you can look into the code, you can look very easily to see the scenario, and you can fix it in, say, half an hour, rather than spending a while working out why it's occurring. And that helps drive us into more of a test-driven approach for fixing those hard-to-find bugs, because you can create your test cases based off the real-life data that's coming in, and if necessary, you can mock out things here as well based off their results. So you can provide a much better test-driven approach as well. And finally, not on this slide, another benefit it also gives us is it empowers the developer. So it enables you to be much more a DevOps approached way of working, so that the developers have all the power and all the information they need. They can find the problems, they can fix it, they can release a new version without calling on ops. Prior, when we were going through this sort of thing, we had to involve ops. We had to ask them to put a new release on. We had to ask them to get the logs, tail the logs, switch it off when the error occurred. Now instead, the developer can see it in real time. The developers in our environment can switch off machines. They can roll and roll back versions. So with OverOps, they're able to really take power and control over the whole environment. Okay, so that's how we are using the TripAdvisor.
So the idea is to make this an interactive session, and if you guys have questions, we're going to answer them. So whether it's for the TripAdvisor team or for the OverOps team, we're here to kind of give you guys some more clarity on when you guys have questions after listening to both of those. No questions?
Yeah, sure.
You mentioned that there was only a 3% CPU hit to run the OverOps agent. Is that under normal conditions, or is that when the system was spewing exceptions?
So even under your Black Friday events, this is designed specifically to take no more than 3% CPU. We do this because we're a separate native agent. We're not a Java agent, right? We don't add your heap space, don't add your garbage collection. And so the reality is, what we'll do is we'll guarantee that we don't impact you. So even if you're at 98, even 99% of your CPU, we'll make sure we take only what's very important to snapshot. If we've seen that error before at velocity, we're not going to spend the time capturing it. We'll make sure that you get the information you need. So we're designed specifically to handle those Black Friday events that you have, right, and that our customers have, right? Whether it's the Comcast of the world dealing with their Xfinity platform during the Olympics, per se, right? The largest viewing that they had, being able to handle them at peak capacity, right? Or really any of our customers. But this is what it's designed for. And then even to you specifically, what you've seen.
Yep, so the overhead we've seen on CPU is negligible. We haven't had any issues with CPU. It does take a little bit of memory, so it can take, I think, up to 5% of your memory. Now, when we first put OverOps in, some of our instances were running very close to maximum memory, so we had to dial down the XMX, or we reconfigure the environment slightly just to give it that little bit extra memory so we don't swap. But as Nick said also, if you do get like millions of exceptions occurring, then it only samples and gives you the full details of a few of those, so the overhead of network and CPU is negligible for us.
Do you mind if I ask a follow-up question? In the UI, I noticed most of the sample variables were simple. How does it handle complex objects?
Sure. Let me, I'll actually show you that. So the question was, how do we show complex objects, right? So these we're going to go 5 layers deep into the heap or into the object itself. So if we look at directly into the heap, right, into the thread local state, we can actually go ahead and pull the entire thread local state, right, as really as a JSON. We can also do this if you look at the payload that came in from the previous application, we can do the same, right? And so now you have literally 5 layers deep into the heap or into the actual object. So if you're 7 layers deep or 8 layers deep of nested objects, yes, we're not going to have that for you, but you will have 5 layers deep into your nested objects. So the reality is what we did was we originally started about 3. We realized that our customers wanted to go deeper. We set it at 5, and now no one's complaining, to be honest. So that's kind of where we keep it. Traditionally, that's been fine.
So the question is, did you see any latency in the API calls because of this OverOps?
No, we haven't seen any latency. There's probably other areas where we're lacking in performance where we could improve. Nothing to do with OverOps, just our code generally. But I don't know if it's, I believe it works asynchronously anyway, is that correct?
Yeah, so the way we snapshot is literally that shared piece of memory that we share between both your JVM and our separate agent. So we're not going to increase your latency. Only when you throw this error exception will we actually capture that memory, but ultimately to the point it's not going to increase your latency. It's a separate call, so it's not part of the JVM. Unlike you will have JVM tools, the Apm tools that will actually increase that latency, and you have to bake that in. Fortunately for you, with OverOps, you don't have to incur that penalty.
Where do you store this information? Do you send it over to the network, or do you store it on disk?
So the question is, when we store this, where do we store it? Where do we store it? So perfect. We actually have 3 different deployment methods. So we offer you the ability to do this in the cloud, right, where everything, in all 3 of these, everything's wrapped in an AES 256-bit encryption key of your choosing, right? So we can store this in the cloud, so it will be stored on Amazon. We do also offer a full on-prem version, which a lot of our big telcos, some of our massive credit card companies do leverage. But most of our users use the hybrid model. The hybrid model allows you to store the source code, the stack trace, the entire variable state, and the logs all on your network, right, with zero internet connectivity on a storage server of your choosing. And then ultimately, only the analytics go to the cloud. So this would be the metadata about how many times we've seen that error, first seen, last seen, so we can get minute-to-minute aggregations. And you can actually, what I haven't shown is get down to very specifics, right, of exactly what's going on inside the system to the minute-to-minute statistics. So those types of things go to the cloud. The rest of it can stay on-prem, but ultimately we offer all three versions. So we'll meet whatever regulatory or security commission you need. That answer your question? Perfect. One more up front. You get to run the mic. Or I can repeat your question either way. Oh, perfect.
How much setup does this product require
Wonderful.
to show all these dashboards and?
Perfect question. I don't know how much we owe her for that, but this is a 5-minute install with 0 source code changes. There's nothing you have to do but add one VM argument. I'll show you what that looks like. I switched to my developer key, so I've got my production key here. I've got my multiple keys that I can have, right, for different environments. And ultimately, I can go quickly to add server, right? So whether you're doing this as a Docker container, we're going to give you the Docker files. Cloud Foundry will give you the setup for that. But ultimately, you can do this as simply as a one-liner. Right, first part says get my install. Second part says use my AES 256-bit encryption key. So that everything that I'm connecting to, I'm going to make sure that's wrapped in that. Once it's installed, it's a native agent. It does nothing until you actually attach a JVM. So the cool part is, and again, we've got it for all your developer operating systems. We've got it for Docker, Cloud Foundry, your advanced tools like Heroku and Elastic Beanstalk, or even your automation tools like Chef, Puppet, Ansible, SaltStack. So you can deploy this quickly. Once you install, again, I say a 5-minute install, probably take more like 90 seconds. Then really it's just changing it. And how many people use Tomcat in the room? Okay, we're going to click that one just for fun. And what we're going to do is show you exactly what this looks like. We're simply adding one VM argument to your startup script. So to the Catalina ops in Tomcat, if you're using JBoss, ultimately before you actually start your application, we're adding one simple line, which is agent lib to keepy agent. You might have heard of us. We were Takipi before. That was our previous name. The agent's still the same, but same company, just new name. The idea is all you have to add is one line that says use our agent. That's it. So now, regardless of whether it's your code, third-party code, so forth, you can start this up with one line after the install. It's per JVM pricing. There's no setup.
I would say that one thing that we found very useful was when we first put it in, is to make sure you've got 1 or 2 people going through and setting up all the shared views, so that when all your other developers come on board, they're not trying to work out exactly what to see. So I think Nick showed one before, these sort of things. So showing you errors that occurred on certain applications in the last hour and things like that, very important for deployments. So doing a little bit of setup work makes it a lot more friendly for other people to come and use it later.
Here's that view that I created for all the S3 errors, but another one of my favorites is all the null pointer exceptions that we're throwing right now. And we actually just had a code release, so we have 5. Normally I have about 1 up there. But the reality is this is neat. So now you can look at every null pointer exception you have in your entire environment, right? And with one click, you can get to them, right? So, but you can set up these. And again, any of those views that he talked about setting up can also be alerted on. So you can be emailed, you can be Slacked, you can be HipChat, you can be PagerDuty, you can open up Jira tickets automatically. So. Questions back? You gotta run that mic. Is this good? Is this what you guys wanted to see, by the way? Yes. Who doesn't? Doors over there. I'm just kidding.
Hi. Does it increase the risk of heap inspection of some sensitive data? For example, if the exception occurs at authentication, and then you get all the, for example, passwords.
Perfect. That's what that Pii redaction is for. That's what they use specifically for the credit cards, but it can be used for any value, right? So whether it's your passwords, whether it's your tokens, whether it's your certificates, right? All of those can be blocked so that you can redact them at the source, meaning they never get written to disk and they never go across the network. That way you can actually meet all of your security or regulatory needs. So we can block all of those for you. So they'll just come up as asterisks as opposed to values. There was other questions right here.
Before I ask my question, I want to do a follow-up. I think the question is about what if the error happens in decrypting or encrypting the thing?
Sure, if that throws an exception, right, that'll be perfectly fine. But literally all of those variables that were told us not to capture, we won't still. So unfortunately, because of your security or regulatory commission, you can blame them, not us. So we won't capture what you don't tell us to. And so if you're getting a weird key or you're getting a weird token, unfortunately, for your security reasons, we're not going to bring that back for you. And that's actually by law. So that's not us, that's by law.
I guess does it then tell you some information that can help you reduce the effort? I guess like in that situation, you have to go through the previous.
Yeah, you'll have the whole
step.
payload from the previous set. So what you'll have on any one of these, right, is that payload that came in from the previous portion of the application. So you'll have that full payload so that you can, either attempt to recreate this, right? So here's that variable. You can actually grab that whole payload, right? And so you have everything that came in from, let me scroll, everything that came in from that, which will allow you to then recreate it if you have to, so that you could get to it. But again, I can't change it. It's like science, right? I can't affect science or law.
Thank you.
Not a problem.
My question is, for TripAdvisor, like, how did you make the decision to use OverOps versus, I don't know if there's other competitors?
Well, we didn't find any other competitors. I'm not sure if there are, but I certainly haven't seen any since using it as well. But we used it or brought it on, say, after a very painful project, which went live, and then we had to roll back, and it was just a disaster. There's a lot of investment in it, and we had to move forward somehow. And providing this sort of information, and also within a PCI environment, it was the only real option we had almost. The other option would have been just to log massive amounts and use Splunk or whatever to try and work things out later, but that's reactive rather than proactive in a way.
And then I'll, to answer the question, fortunately for us right now, we have zero competition. Our only competition right now is time and money. And so it's a good place to be. Now, I'm sure there will be at some point in time a competitor, but right now we're the only ones that will actually provide this for you, provide you that state information, in your production systems. So, like I said, there's a lot of other tools that do performance and that do the logging, but when you want to get to the why, right now we're the only name in the game, which is kind of cool. So, one of the things that I didn't show you, and we'll have your question as well. One of the things we do actually keep track of your code changes for you, which is interesting. So when you actually want to see, and this error had something interesting. So you'll notice we showed you where the error was thrown, right? We showed you where the error was caught. But also if we scroll down, we can see there's these little pen marks next to some of these methods, and you'll actually notice in that tiny little text, it says that this code was modified 3 hours before the error was first seen. So we'll actually show you, like you updated your code and then you threw this error, right? And we can show you when that happened. So the benefit is when you're releasing that new code, not only do we have views set up that you can get to that, but you'll actually visually see it, what code changed. So we keep track of all of that for you. Again, you don't have to worry about that. As your stack changes, as your code changes, we maintain that for you. Question?
Yeah, that was one of my question. And the other question I had is, how do you link the source code to this application?
Perfect. So we can get the source code one of two ways. So by default, we're going to show you decompiled Java, right? So we're going to show you exactly what executed at runtime. This is beneficial if you're using Java. However, if you're using something like Scala or Clojure or JRuby, that's not going to look anything like decompiled Java. So we do also offer you the ability to attach your source, right? Which then allows you to see your notes and your line by line. What I can do actually is demonstrate that. So I can grab, I've got an example that uses Clojure. Don't know how many people here use Clojure, but it's not like Java in any way, shape, or form. But what we can do is actually show you, and hopefully I think I've got some that have notes. So let me see if I can find some really quick. Come on. I'll get there. Here we go. So you'll notice here in the blue, right, this says is a middleware that converts and redirects. So that's your notes coming in from there. So this is actually an attached set of source. What was interesting is we originally worked with like the GitHubs of the world and so forth. But what we found was that people were actually attaching the wrong branch. And I don't know if you guys have ever troubleshot on the wrong branch, but it's about the most painful thing on the planet. Just stab yourself in the eye, save yourself the time. So the idea was that wasn't going to work. So what we have was a way that you can actually build it into your build process, so that now you can land your source in that secure storage area and then reference back to it during your build and during your deploy. So it makes it just a one-time config to be able to set that up, and then you can version control it after that. Any more questions? Sweet. One more. Two more. Oh.
In terms of capturing, you just capture the entire stack from leading up, let's say, entry point to where the error is. But let's say I write some really fun log-free, wait-free algorithm, and another thread actually caused thread A where the exception occurred to start happening. Is there some way you can capture across the threads as well? Or?
Yeah, so what you'll see, like Spring specifically does a ton of rethrows. I don't know if you guys are familiar with Spring. So we see that, right? And you'll actually get what's called related errors. So you'll see all the related errors and the rethrows that you see from there. And then the one question about actually crossing the different stacks. So that question traditionally comes from people who use Apm Tools, because that's how you actually get from what your original data looked like all the way to where you are and where you erred. The benefit is you don't actually need that. You just need the payload that came in from it and wear it through the error to get back to it. And we give you that all in one screen. And I say this because I've watched everybody ask that question, and then when they start using it, they're like, yeah, why do I need to know what happened before? I only care about the payload that came into this portion of the application and where it erred. If Steve, I don't know if you want to talk about that specifically. Or?
Yeah, we've never had the requirement or never found a problem that couldn't be solved. Sorry. Yeah, we've never actually had that as a requirement to look across stacks to see what was going on. I can understand why you might think that, but at the end of the day, you can still defensively code or fix the bug that caused that error, even if something else is doing something funky elsewhere. But no, that's never really come up.
Good question, though. That actually comes up from most of our APM users. So, perfect. One last? We got one more over here. Question, sorry.
So we are currently using Cabana to store all the logs. So can you still redirect all those logs to Cabana?
Perfect question. So what I was showing you earlier, right, as your logs, we're going to, by default, we're going to inject this tiny little link every time that we throw one of those errors or warnings. That's going to happen without you doing any configuration, meaning regardless of whether it's Cabana, right, or if it's Sumo or Splunk, because they're already hitting your logs regardless, they're going to be picked up by those log analyzers. So they automatically get injected. So you will have, if you're sifting through those logs wondering what happened, you can literally go, well, with Splunk you'll have to copy and paste, but at the end of the day, double click and get right to that source stack and state. So you don't have to do any integration. That happens automatically. You'll start seeing those in your logs today. The benefit here, and I'll just tell a funny story. We had one of these huge financial institutions. He got on the phone. He was really mad at me. He was really mad at me because we saw 4 null pointer exceptions that he didn't see in his logs. And he was furious that why we were seeing these. And then when we realized, and he realized, that he wasn't actually logging them, and they've had 4 null pointer exceptions for quite some time, he was really happy at me because, of course, they were able to solve them. So it's not even just about what you do log, which is great, and you'll see that. But even the things that we either forget to log or we don't log, or for that matter, even those uncaught exceptions, will still have that same visibility into that level as well. Cool. Well, I want to thank you guys. Hopefully this was a good session. I hope you enjoyed it. Please stop by the booth if you want, and we're more than welcome to set up a meeting and so forth with your teams. Really appreciate it.